This is the first part of the notes for section 14.2 on gas laws. Gas laws are just some different equations that we're going to be working with different properties of gases. There's three different gas laws that we're going to look at in this portion of the notes. Gas law is called Boyle's law. It's not really important that you know the names of the laws. It's important that you know how to work with them though and what they mean. But Boyle's law deals with pressure and volume. So it states that for a given mass of gas at constant temperature, the volume of the gas varies inversely with pressure. So for something to vary inversely, if things are inversely proportional, it means if one factor goes up, the other one goes down. So in this case, if the pressure increases, the volume is going to decrease. With pressure, P1 and P2, the units, most of the time they'll be in kilopascals, but they can also be in atmospheres or mmHg. It really doesn't matter as long as they agree, and that just means they have to be the same on both sides. Then you can't have P1 in atmospheres, P2 in millimeters of mercury. They have to be the same on both sides. With volume, that could be milliliters or liters, and same thing, the units just have to agree. You have to have liters on both sides or milliliters on both sides. And we have the ones here. The ones are usually your initial or starting conditions. The twos, like P2 and V2, those are your final conditions. So it starts with this and it changes to that. The second gas law equation is called Charles's law. And that states that the volume of a fixed mass of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. So constant pressure, constant amount of gas, the volume and temperature, they're directly proportional. So when things are directly proportional, it means that they both increase or they both decrease. They go the same direction. And along with that, they go the same direction by the same factor. So if the volume doubles, the temperature also doubles. Or if the volume is cut in half, the temperature is cut in half. The units for this volume, again, can be in milliliters or liters. Again, they just have to agree though. Temperature, though, has to be in the Kelvin scale. And in a lot of the problems, you'll see temperature given in degrees Celsius, and you just have to add 273 to that to get it to the Kelvin scale. So it's important that you remember that. The third gas law is called Gay-Lussac's law, and that states that the pressure of a gas is directly proportional to the Kelvin temperature if the volume remains constant. So this deals with pressure and temperature, and again, they're directly proportional. That means they'll both change the same direction, either up or down, by the same factor. So again, you have the ones, those are your starting given amounts, and the two, that's what it changes to. Those are your final conditions. So it's pressure and temperature. And with the units on this, again, temperature again has to be on the Kelvin scale. For this chapter, whenever you see temperature in an equation, it has to be Kelvin. Pressure can be, most of the time it will be kPa, but you could also see atmospheres or mmHg. But again, they just have to agree. P1 and P2 have to be measured in the same units of pressure. A couple of practice problems. The first one says a sample of neon gas occupies a volume of 677 milliliters at 134 kPa. What is the pressure of the sample if the volume is decreased to 642 milliliters? Alright, so with this problem now we have volume, and then kPa is the unit of pressure, so that's a pressure, and it says what is the pressure, so that's what we want to find at the end, and the volume is decreased to 642 milliliters. So we have just volume and pressure. There's nothing about temperature. So this is going to be Boyle's law. So the equation for that is P1
Grace Larson to the attendance office. Grace Larson.
times V1 equals P2 times V2. That's the first thing you want to do with these gas law problems, is figure out what variables do we have, and then look at your list of equations and figure out which one fits the information that you're working with. So again, we have volume and pressure, so we want to use Boyle's law. P1V1 equals P2 times V2. Alright, so now we want to plug the information into the equation and solve for the unknown. So we're looking for the new pressure. So P2 is going to be what we solve for at the end of the problem. The ones are your starting conditions. So we're starting off with 677 milliliters, 134 kPa. So we can plug those in. So P1 is going to be 134 kPa. V1 so that's milliliters, and that's equal to P2, that's what we want to solve for, times 642 milliliters. So we just take the equation that we have, we plug in the numbers that we know, and now we just want to solve for the unknown. So we just want to divide both sides by 642 milliliters. So we isolate P2, 642 on each side. On the right side, those will cancel out. Now you have P2 all by itself. So it's going to be 134 kPa times 677 divided by 642. The units of milliliters cancel out. And when I do that, I get P2 is equal to 141.3 kilopascals. And now this is helpful if you think about the answer, if it makes sense. So pressure and volume are inversely proportional. So if one increases, the other one decreases. We had 134 kPa, 677 milliliters. The pressure dropped, or excuse me, the volume dropped to 642. So you'd expect the pressure to increase a little bit, and it does, from 134 to 141.3. The next practice problem says a balloon inflated in a room at 24 degrees Celsius has a volume of 4.00 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What is the new volume if the pressure remains constant? Now, if you see something saying that something remains constant, it's not going to be part of your calculation. So pressure, we can pretty much cross that off. It's not going to be part of our calculation. We have a temperature, and we have a volume, and it's heated to a new temperature. We want to find our new volume. So with volume and temperature, that's going to be Charles's law. So with Charles's law, that's, let's see, V1 over T1 equals V2 over T2. Now, the real important thing to remember here, the temperature in the equation has to be in Kelvin, so we're going to have to make those conversions. So T1 is the temperature that we're starting at. That's 24 degrees Celsius. So we're going to add 273 to that. So that's going to be 297 Kelvin. Then T2 is going to be your final temperature. That's 58 degrees Celsius. Again, add 273 to that, and you get 331 Kelvin. Okay, so those are the temperatures that we're going to put into the equation over here. So V1, that's our starting volume. So that's going to be 4.00 liters. Starting temperature is 297 Kelvin. V2 is what we're trying to find. We're trying to find the new volume. And then T2, 331 Kelvin. Okay. Now, when we have a setup like this, we want to cross multiply and divide. So when we cross multiply, it's going to be V2 times 297 Kelvin equal to 4 liters times 331 Kelvin. Now we'll divide both sides by 297. So we want to isolate V2, get it all by itself. It's 297. On this side it cancels out, so it ends up being 4 liters times 331 divided by 297. And when I calculate that, I get V2 is 4.46 liters. Okay? And again, you'll want to think, does this answer make sense? Volume and temperature are directly proportional. So you started off with 4 liters and you started off with 297. Kelvin. The temperature went up, so you would expect the volume to go up a little bit too, and the volume does go up to 4.46. So this is an answer that makes sense.